It is a well-known general fact that with the neglect of water vapor, Earth's atmosphere, or the air that we breathe, is about 78% nitrogen gas, 21% oxygen gas, and 1% argon gas, besides smaller but not unimportant amounts of other gases, such as carbon dioxide gas, where such values represent percentages, fractions, or ratios for amount of substance, number of moles, number of molecules, or volume, all equivalent to each other here. In other words, dry air is roughly 4/5 nitrogen gas and 1/5 oxygen gas, besides small amounts of other gases, of which argon gas is the most significant one with 1%. While such well-known general facts summarize well the subject, there are much more details for composition of Earth's atmosphere. So let's have a more precise look at it and see it in more details. Earth's atmosphere, also known as air, is the gaseous layer that surrounds the planet Earth and is retained by Earth's gravity. Based on NASA's Earth fact sheet, Earth's current atmosphere has a total mass of about 5.1 times 10 to the power of 18 kilograms, a surface pressure of 1014 millibar or 1 atmosphere, an average surface temperature of 288 kelvins or 15 degrees Celsius, a surface density of 1.217 kilograms per cubic meter, and mean molecular weight of 28.97. While the atmosphere of Earth has played roles in planetary evolution of Earth, such as evolution of its surface features, Earth's atmosphere has been of crucial importance for creation and sustainment of life on the planet Earth, due to different reasons, from providing suitable conditions for existence of liquid water on Earth's surface, to absorption of life-threatening ultraviolet solar radiation. Over billions of years after formation of the planet Earth, Earth's atmosphere has changed greatly over time due to different reasons, such as volcanic activities, weathering, life, etc. Recently, human activities by burning of fossil fuels and release of carbon dioxide gas into atmosphere has also contributed to change in Earth's atmosphere over time. In addition to its change over time, Earth's atmosphere varies in density, composition, temperature, and pressure as altitude or height from the ground level changes. In this regard, based on characteristics such as temperature and composition, several layers can be distinguished in the atmosphere of Earth, where these layers extend from the surface of Earth to hundreds of kilometers above it, with no definite boundary between Earth's atmosphere and outer space, as Earth's atmosphere gradually becomes thinner and thinner or less and less dense by increase of height. But anyway, 90% of the mass of Earth's atmosphere is found below an altitude of 16 kilometers and less than 1 part per million of its mass is above an altitude of 100 kilometers. The lowest layer of Earth's atmosphere is called troposphere. While in troposphere, temperature decreases with increase of height, in its upper adjacent layer, called stratosphere, temperature increases by increase of height. Troposphere ranges from the ground to the base of stratosphere at about 10-15 kilometers of altitude, depending on latitude and meteorological conditions. Troposphere is the most dense or the thickest layer of Earth's atmosphere and contains about 70-80% of the mass of the whole atmosphere, where the lower part of troposphere from the ground to an altitude of about 5.6 kilometers contain about 50% of the total mass of Earth's atmosphere. Most weather features, conventional aviation activities, and chemistry of reactive anthropogenic or human-made species released into the atmosphere take place in troposphere. While composition of Earth's atmosphere changes by increase of height, we can practically assume that the overall composition of Earth's atmosphere is almost same as the composition of Earth's atmosphere at its lower layers, such as troposphere, or even at sea or ground level. Since by increase of height, when a significant change in composition of air happens, air has become so thin that its contribution to overall composition has become negligible. Besides change in composition of Earth's atmosphere over long periods of times in Earth's history or through different altitudes, there can be local and short-term change in composition of Earth's atmosphere due to different natural and human activities. Where such local and short-term change might accumulate over time and affect the entire atmosphere, or might completely be compensated and vanish through processes such as chemical reactions with soil or sea water. For example, human activities have resulted in measurable increase of carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, and some other species in Earth's atmosphere in recent decades. In this regard, amount of water vapor in air is also susceptible to great local and short-term variations. Amount or mole fraction of water vapor in air can vary from few ppms or few parts per million in air in some cold and dry places to as high as 5% in some hot, humid places. Despite such great variations in amount of water vapor in air, it can be argued that in total, water roughly accounts for about 0.25% of the mass of Earth's atmosphere. Also, to avoid such great variations in amount of water vapor in air, it is common to report amounts of other gases in dry air or in air without any water content. In the context of composition of Earth's atmosphere, we should also consider that for a short or long period of time, locally or over a wide area, air around us, in addition to various gaseous constituents, might contain various solid or liquid particles, such as dust of mineral or organic composition, fog, sea spray, volcanic ash, pollen and spores, smoke, soot, etc. In some cases, composition of air without its possible liquid and solid particles, for instance after filtration, is reported. While in other cases, such as analysis of air pollution, amount of suspended particles might also be of interest. As we can see, composition of air is variable with respect to several of its components, such as water vapor, carbon dioxide, methane, etc. Therefore, it is hard to define pure air, or even pure air has no precise meaning. Yet it is common to consider pure air as the air which is free of dust or in general solid or liquid particles of any kind, and also free of the reactive gaseous contaminants of anthropogenic origin, where reactive species will exist only for short periods of time in atmosphere. In addition, composition of atmosphere is generally reported for dry air to avoid great variations in amount of water vapor in air. Therefore, for composition of Earth's atmosphere, we generally consider dry, pure air, which is free of solid and liquid particles, water vapor, and human-made short-lived reactive gaseous contaminants. Finally, with consideration of such facts, we can have a better understanding what in fact is generally reported as composition of Earth's atmosphere. Based on NASA's Earth Fact Sheet, atmospheric composition by volume for dry air at surface is as follows. As major constituents, 78.08% nitrogen gas, 20.95% oxygen gas, and as minor constituents, 9,340 ppm argon gas, 415 ppm carbon dioxide gas, 18.18 ppm neon gas, 5.24 ppm helium gas, 1.7 ppm methane gas, 1.14 ppm krypton gas, 0.55 ppm hydrogen gas. Here, numbers don't add up to exactly 100 due to runoff and uncertainty. Anyway, here we can see there are many amazing facts about the composition of Earth's atmosphere. This is interesting, isn't it?